Hello, welcome. This is CH Arvind Kumar, Assistant Professor, Department of Computer Science and Engineering, Vagdevi College of Engineering. I am going to explain Network Security and Cryptography Lab. Week 8 program. Write a program to implement RSA algorithm. RSA algorithm is a public key cryptographic algorithm. So first we will discuss what is public key cryptography. Then we will discuss RSA algorithm. Public key cryptography, probably most significant advance in the 3000 years history of cryptography. In public key cryptography, two keys will be used. One is public key, another one is private key. Why public key cryptography? Public key cryptography developed to address the following two key issues. The first issue is key distribution. In symmetric key cryptography, secret key in between sender and receiver is shared by key distribution center. How much we can trust key distribution center? So, to avoid third party to share our keys without having a key distribution center, how we can share the key? This is the first idea and first issue. Second is digital signature. How to verify a message comes intact from the claimed sender. How you are going to trust the message is coming from actual sender? We need one proof the message is coming from the sender. Based on these two issues, the public key cryptography is developed, and it was developed by Whitfield, Duffy and Martin Hellman at Stanford University in 1976. We will see how public key cryptography will work. Assume there are two users, Alice and Bob. Both are communicating with each other. Both users generate two keys. One is public key and private key. In the same way, Bob also generates public key and private key. Now, Alice share her public key with Bob. In the same way, Bob shares his public key with Alice. Both users publicly exchange their public keys. Now, Alice sending one message. That message is encrypted with Bob's public key, receiver's public key. To encrypt this message, one of the public key cryptographic algorithm is used. By using the public key of Bob, the message is encrypted. This encrypted message is forwarded to Bob. Bob uses his own private key to decrypt the message because Alice uses Bob's public key. To decrypt the message, Bob's private key must be used. So Bob uses his own private key to decrypt the message. The message is decrypted. In this way, the public key cryptography is worked. One key is used to encrypt the message, another key is used to decrypt the message. RSA algorithm is the best known widely used public key cryptography algorithm. It was invented by Rivest, Shamir and Edelman of MIT in 1977. By taking the first letters of the scientists' names, the algorithm named as RSA. Rivest, Shamir, Edelman. First we will see RSA key setup. RSA is a public key cryptographic algorithm. So it will generate two keys, public key and private key. For that we have to follow the following step. The first step is select two prime numbers P and Q. Then calculate n equals to P into Q. Next, calculate Euler quotient, that is pi of n. Pi of n equals to P minus 1 into Q minus 1. Next, select encrypting key E by following these two conditions. E must be less than pi of n and the greatest common divisor of E and pi of n is equals to 1. Next, calculate decrypting key D by using this equation. E into D equals to 1 mod pi of n and D must be less than or equals to n. Now we have encrypting key E and decrypting key D and the maximum length of the message. By using these three values, we are going to calculate public key and private key. So we are going to publish the public key for encrypting. Public key PU equals to E comma n, and we'll keep the private key as a secret, and this key will be used to decrypt. So private key PR equals to D comma n. Now we'll see encryption and decryption by using RSA algorithm. To encrypt a message M, the sender must obtain public key of recipient. Means both the users must exchange their public key. So we have our public key PU equals to E comma n. By using this public key, we are going to perform encryption. If we perform encryption, we'll get ciphertext C. So ciphertext C equals to m to the power of e, message to the power of encryption key mod n, where m must be less than n. To decrypt the ciphertext, C, the receiver must use his own private key. Private key PR equals to D comma N. By using this private key, we are going to decrypt the message. If we decrypt the ciphertext, we will get plaintext message M. So to generate M, we are performing this operation C to the power of decryption key D mod N. Here the message must be less than N. By using these two equations, we are going to perform encryption and decryption. Now we will see one example for RSA algorithm. First we'll start with key setup. To generate key, we have to follow the following steps. First step, select two prime numbers P and Q. So here we selected two prime numbers 17 and 11. Next calculate n equals to P into Q. So n equals to 17 into 11, that is 187. Next calculate Euler-Thomson pi of n equals to P minus 1 into Q minus 1. So pi of n equals to 160. Next select encryption key by following two conditions. E must be less than pi of n and greatest common divisor of E and pi of n equals to 1. So here we selected E as 7 because the GCD of 7 and 160 is equals to 1. Next calculate D. To calculate D, use this equation DE equals to 1 mod pi of n. By using this equation, we got D as 183 because 183 into 7, D is 183 and E is 7. So it will generate 1281. If we perform modular operation, we got the result 1. So it is satisfying our condition. That's why we selected D as 183. From this D, E and N value, calculate public key and private key. So first calculate public key and publish that public key. So PU equals to E comma N, public key PU equals to 7 comma 187, E equals to 7, N equals to 187. Next keep secret key private. So private key PR equals to D comma N, that is 183 comma 187, D is 183 and N is 187. Next we'll perform encryption decryption by using public key and private key. So to perform encryption, you need to have a message. Our message is 88. 88 is less than 187 N. Now we are performing encryption. To perform encryption, use this equation C equals to M to the power of E mod N. To perform encryption, we are using the public key, that is 7 comma 187. E is 7, 187 is N. We are applying these values. So M is 88, M to the power of 7. That is 88 to the power of 7 mod 187. So final result of this operation is 11. Means the ciphertext is 11. This ciphertext will be forwarded to receiver. Receiver perform decryption. To perform decryption, use this equation M equals to C to the power of D mod N. And here we require private key. Our private key is 183 comma 187. By using this private key, we are going to perform decryption operation. We know C value, C is 11 and we know D value is 183 and mod 187 N value. The result of this operation will generate 88, M equals to 88. In this way, encryption and decryption performed by using RSA algorithm. This is RSA program. In this program, I have written the logic for calculating N value, Euler coefficient, pi of N value and calculating D value, how to perform encryption and how to decrypt the ciphertext. Everything is clearly written in this program. Now we will see how to execute this program. To execute the program, open command prompt, compile program. To compile the program, cc space program name dot c minus o will create an output file and any new name for that file. It will create rsa.exe file. To execute the program, directly call this rsa.exe. Now we have to enter two random prime numbers. As per our example, our prime numbers are 17 and 11. So it is calculated N value, N equals to 187 and pi of N equals to 160. These are the possible values for E. Selecting E because the GCD of E comma pi of N equals to 1. So if you take any value from this, it will generate GCD as 1. As per our example, I am taking 7 as our E value. It is calculated D value as 183 and our public key is 7, 187 and our private key 183, 187. Now we have to enter our plain text message and the plain text message must be less than 187. So our plain text is 88. It is generated ciphertext as 11 and after decryption it will generate plain text as 188. Thank you.